f plus g of x is going to give us a new function called the sum function of f and g, and it's just simply defined to be f of x plus g of x. So in this type of case here, where our two functions are polynomials, we're basically just going to add them together and combine like terms. So I'll go ahead and keep them in parentheses for now, even though it's not necessary here when we are just adding, so that we can still just see them a little more clearly and separately, that it's f of x plus g of x. Now I'll go ahead and just remove the parentheses and combine any like terms that we might have. Maybe just rearrange things as well. So I'll put my x squared first plus x, and we do have minus 5 minus 1. Those are like, that's minus 6. So there's our function f plus g of x. Now its domain we would need to find by considering the domains of f and g separately. And so we want to go back here and look at those. So the domain of f by itself, f of x is x minus 5. So again, the things that lead to restrictions in our domain, or things that we're not allowed to plug in for x, would be things like square roots or fractions with variables in the denominator. We don't have either one of those there. We can plug in whatever number we want and subtract 5 from it, and we'd get a number answer. So our domain of f is all real numbers, or negative infinity to infinity. And for our domain of g, we're going to get the same thing. Again, we don't have any square roots. We don't have any variables in denominators, and so we can plug any number we want in there for x. So generally, the domain of f plus g is going to be the interval where the domains of f and g overlap. And since both of them are all real numbers, they would overlap on the interval of all real numbers from negative infinity to infinity. To find the domain, generally we cannot just look at our final answer here of the x squared plus x minus 6. We need to look back at the domains of f and g originally.